Hey everyone, welcome to this crash course for TanStack Query. Now, as they say in the official documentation, it is indeed the most powerful asynchronous state management for JavaScript. Unless your application is all in the client side, you should be using TanStack Query. Now, since it is pretty much fundamental for pretty much all applications, we're going to look at the whole life cycle of using TanStack Query. So for that, I have this monorepo, which I want you to clone and want you to code along with me. It is simply a monorepo with two applications. So we have the client and the server. Now, the client is a React application with Vite or Vite, and the server is with Hono, which is a backend framework for TypeScript. Now, we're not going to be doing any backend development. We'll just see how we can synchronize the state from the server using WebSockets, queries, and mutations with our client using TanStack Query. Now, this is the application. So we have a chat room, we can talk as John or as Melissa, and we can send messages. So we can say hello there, and if I send this, as we can see, there's nothing going on UI-wise, and that's because we need to connect this using TanStack Query. But if I refresh the page, as we can see, we have the message here, hello there. And if I switch over to Melissa, then well, now we're talking with John. So we're going to learn how to handle optimistic updates. So for example, when we type out a message, it should show up immediately. If it's successful, then we should replace the optimistic message with the real message from the server. And if it's an error, then we can remove that optimistic message. We will also be handling error states, so reverting back the message. We're going to pretty much learn how to use TanStack Query as if it were an actual production application. So we're going to see how to synchronize this state with WebSockets, how to handle all of the three states, so optimistic, success, and error, and also best practices, what you should do and what you shouldn't do. Now, if you clone this project, you should be able to just run bun install in the root and you should be good to go. Now we have these two scripts. We have dev client and dev server. So if you bun run dev client, you're going to get the Vite React application at this port. And if you run bun dev server, you're going to get the server running at port 3000. So now let me give you an overview of the project. So if you come here, we have apps and packages. Now apps, here we have the client. So this is the React application. And if I come here over to the server and then to the index, we are just importing API from @org/API, and then we just default export API. Now this is because we're using a shared package for this. Now if I come here to packages, which would be the shared libraries the two applications would consume, and come here over to API, which is this one, we have all of the logic for the server. Now the reason why this is in a shared package and not within the application itself, similar to how we're doing it in the client, is because we need to share the types. And Hono actually gives you a way like TRPC to easily communicate between your client and server, doing it all in code without manually typing out everything. So that's why the server, well, must consume this API that we're exporting here, and the client is going to get the type safety from this package, which is this one, export type API is equal to type of router, which is all of our application code. And we're also exporting the WebSocket events. So again, our client knows what events we're going to be handling. Now don't worry too much about this, it's pretty basic. We have an endpoint for getting all of the messages for the chat, then we have a post for the chat, and here we validate against a sort schema. So a message is an ID with CUID2 as the ID, then we have as, which is an enum, so John or Melissa, then we have the content, which is the body or the message itself, which is a string, then we have read add when it was read, and then we have created add. So this is pretty basic as you can see, and this lives in another package. This lives in API contract. So this is where we would share the types and whatnot. And then here in this resolver, we're just using effect, which is a great library. I've been using it a lot lately, but the reason we're using this library instead of just a function is because I want to simulate a computation that takes some time. So we sleep this handler for 2 seconds. That way we can handle the optimistic updates and see everything. Because since we're running everything within the same machine, once you send a message, it is going to be processed by the server instantly. So we would never see the optimistic cycle of the messages. So that's why I added this artificial sleep for 2 seconds. And then we have the logic. So we create the message, we push the message, and then we broadcast the message to every WebSocket connection. So type new message, and if I come here, it is just a function that is going to iterate over all of the active connections, and it is going to send the JSON.stringify event. And if I come here to WebSocket events, it's just a union, or rather a discriminated union, where we have the type for new message, type read message, and then we have the 2 messages that the server should send us. So in the client, we'll see how we can handle the updates in the cache for these 2 types. And that's pretty much it. Then we have the patch for read. So this is to mark the message as read. So we need to send over the ID of the message and read out. We have no authentication, no authorization. We want to keep things simple so that we can learn the application inside out. So here it is pretty rudimentary. We just search for the message and we update the message, and then we broadcast another message saying, hey, this was read. And we pass in the message that is now read. And then we have the WebSocket channel. So here we're using on for everything. So when it is open, we add the connection to the set, and on close, we just log to the console connection closed. And that's pretty much it. That's the whole backend. Okay, so now let's take a look at the client. So if I come here to apps, then /client, we have the Vite application. So here we have a path alias using TypeScript. And here, as you can see, we map at to everything within source. And we're using Tailwind for the styles, but well, we're not going to be playing around with the UI itself. Now, if I come here to the main application or the main component, we have React.strict mode, and then we render the chat. So this is like the root of the whole application. Now, if I come here to chat, we are rendering a div with the chat header, the message list, and the chat footer. So if we recall, and if I come here, this is the header where we have these 2 tabs. This is the chat list, and then we have the chat footer. So if I come here to the chat header, for example, I don't know why VS Code is not opening it up. As you can see, we have the chat room, so the title, and then we have another component, which is as tabs. And if I come here, we have the 2 buttons. So we're using sustand to persist the as state. So between John and Melissa. As you can see, we render the 2 buttons, and then we just toggle between them. So set state as, and then, well, this is John, and then this is Melissa. And then we have the session, so use, or I didn't name the file correctly, so this should be named as use sender session, so we can find it easily. So here, use sender session, and I believe there's somewhere else where I'm using it, but we'll do that later on. So as we can see, it's just a value. So we have as John, and then, well, this can be Melissa. So pretty basic, nothing too fancy. And this is it for this toggle. Now, if I come here to the chat component and then come over to the chat footer, we're using the client to make the mutation, which we'll see in a moment. So this chat footer is the form, so we can send a message. So here we have on submit, and we have the function, and then we have the send button, and then we have the input with a controlled value. So we're using state for this. Now, as for the onSubmit, we trim the message and we check that it isn't an empty string. If it is, well, we just bail out. If it isn't, we make the mutation here. So we use client.chat, then post, and then we send the JSON information. So we just send the as, the content, and when the message was created. basically. And after this, we just clear out the message. Now we're not using a wait, so in fact, this will be done first before reaching or resolving this promise, but we'll see how we can improve this with TanStack Query. Now, as for the client, what is this? Where does this come from? Well, this comes from, if I reveal the file, from lib/client. And here we're just importing the types from the shared package, which is the API, where the API core lives. Now, in fact, this should be all within a type import. And the reason is because if we ever slip through and pass in something that isn't a type, so actual application code of the API, then the front-end code will explode because, well, we're trying to set up a WebSocket server and other things that do not exist in the browser. So it's important to mark this as type, so that, well, TypeScript only brings us the type information, but it won't actually be bundled in the build of the client. And then we import HC, which is the HANA client, and this one gives us the type safety. So here we say HC, then we pass in the generic, which is the type of the API, and then we just pass in where the server is. And we do the same with WebSocket. So for WebSocket, we say client.websocket and then WS and then 0. And that way we get full type safety. So if I come here and say client dot, then we have the chat and WebSocket. Now, why the chat? Well, because if I come here, we just have chat. So /chat. If we were to have something else, then we would get that type safety as well. So if I come here, we have chat. So again, this is saying /chat. So here we can say get, and now we get all of the information, and we can say post, and we send over to the server a message. So again, JSON, and then we pass in the information which it expects from this one right here, from the schema, because we're meeting the ID. We do not care about the ID. Why? Because, well, the server is the one that generates the ID. And that's pretty much it. So again, this is just a wrapper. So this is behind the scenes, just doing like your usual post fetch or get fetch, whatever it is. Now, if I come here again to the chat, we have the message list. So if I open the message list, we have the messages, so in state, and then we have a use effect. And here we just perform the get, then we get the JSON, and this is all via the power of TypeScript. So again, as you can see, we have all of the types, and then we can just say that then set messages. And this will be invoked when the component is mounted. And then we have this use layout effect to scroll to the bottom whenever messages change. Now, can you see a problem with this approach? Well, you're not handling loading states. You're not handling pending states. Perhaps you want to execute the query if a condition is met. You're not handling retries. So what if this fails? Will the user have to refresh and try again? There are so many things that are missing from this approach that, well, you should never do this. And this is in fact what TanStack Query does for you. It provides the retries, provides the success values, the error values, if it's pending, if it's loading, and so much more. So we'll see how we can refactor this to use TanStack Query. Now, once we get the messages, assuming this was successful, we just render a scroll area. This is from Radix, and we render each message. So we render the message bubble, and we have an empty div, which acts as the bottom of the whole chat. So if I come here to the message bubble, so message bubble, here we have the as, and then we get the sent by. So we pass in each message and we determine if it's the current user or the recipient. So as John or as Melissa, depending on their perspectives pretty much. And then we have some styling. We render the avatar, we render another div with the content of the message, and then we render the status icon. So this will be the one where it is going to tell us the state of the message. So for example, one check, is it was processed by the server successfully and the recipient received the message. And if we have two checks, so such as this one, that means that the message was read by the other user. And we have the clock icon, which we do not have here, and that is for optimistic messages. So if I open up message status icon, as we can see, we have optimistic, sent, and read. And then we have get message status, we pass in the message, and we use TS pattern to easily determine the status. So when the ID starts with optimistic, then we know that it is optimistic. If read is not nullable, meaning that it has been read, so the value is not null or undefined, then we return read. And for any other case, we just say otherwise sent. So this is like using a switch statement, but way better. It is cleaner and you get great type safety. So I strongly recommend using this library TS pattern. And then we have the message status icon. So we retrieve the message status and then we just switch upon it. So we're using the factory pattern where we render a different component depending on the message status. Now, the reason we're not doing it here, such as saying, okay, this will render a clock icon, this will render a check icon within the match statement, is because React is going to recreate this function over and over again per every single render, meaning that it has no way of knowing if the component actually changed, because as far as React is concerned, this is completely new for every single render. So that's why you should always use a switch statement and never use functions to render the actual components. And that's pretty much it. That's the whole application. Now, actually, before integrating TanStack Query, I decided to virtualize this list just to make it easier when we want to keep the user scrolled at the bottom whenever they type out a message, for example, and also just to follow best practices. You would usually virtualize your list because, well, if the user is going to have over 5,000 messages, you shouldn't render the 5,000 developments in the page. That's going to kill the user's RAM. So for that, I used React Virtuoso, but the usage is actually very basic. All I did was create this ref for the library and then the scroll parent, and then I created this useHandleIsAtBottom hook. So here in the render, what I did was use the scroll area from Radix UI so that we get this nice scroll bar. And then I passed in the Virtuoso as a child, and then I passed in the ref, and then the data. So these are the messages that we're going to be rendering, and then the item content. So this represents each row. So here I just memoize this component. We get the index as the first argument, and then the message, which is the data type of this data. So this structure right here, we're going to be receiving that here, and so we can still render it however we want. And then we have the follow output. So we've set to true, the list automatically scrolls to bottom if the total count is changed. Set to smooth for an animated scrolling. If we want to implement an arbitrary logic behind that, we can pass in a function, so we get the isAtBottom boolean, and then we can do whatever we want. So here in the follow output, in the useHandleIsAtBottom, we have this callback and we just calculate the isAtBottom. So if the user is within a threshold of 15 pixels to the bottom, then we know that it is at the bottom. And the reason why I'm using a custom isAtBottom boolean is because the library for some reason does not support this property right here isAtBottom when you're using, say, scroll area instead. So we need to do that imperatively. And then here, just a use effect, we add the event listener to the scroll, and then the follow output, and we check if it's at the bottom, then smooth. Otherwise, don't do anything, so do not scroll to the bottom. That way, when the user is scrolled down to the very bottom, or just a little bit off, so 15 is the threshold, when we type out something and a new message is rendered, it is going to stick the user to the bottom, like any other chat does. Otherwise, if you're beyond that threshold, then it is not going to scroll you down. And that's pretty much it. So nothing too crazy. Okay, so now let's install TanStack Query. So I'm going to come here over to the official documentation, getting started, and then installation. And I'm going to copy this bun command, and I'm going to come here and cd over to client. So cd apps, then client, or rather just client because I'm already within apps. And then we can run this command. Now we're getting an error here. I believe this is because bun sometimes decides to not do anything in the installation. Something went wrong. So I'm going to remove the bun.lock and then remove the node modules directory. And let's see if that works. Client again. Seems like we need to first install it at the root. So bun install. And then we can cd into apps client and then install this, and now it works finally. So now we can come here over to the root of our application, which should be this main right here. And within this one, we're going to simply copy what they have here. So should be here in the quick start. They create a query client. Now this is very important. So I'm going to copy that query client. I'm going to come here over to lib. And then within the same file, we're creating the WebSocket connection and the client for HONA. I'm going to copy this and I'm going to import query client. So VS Code is not helping me. So from @TanStack React query, and I'm going to export this. And then we can come here over to main, and then we can pass in the high order component query client provider. So here, and we can import that from again @TanStack/React query, and we can import the query client. And now we can start using TanStack Query. So in fact, let's use the DevTools. Here, if I come to the DevTools page, we can say bun add, and we can do the exact same. So again, this is not working again. And then we can see the bug into apps client. And it should be working now. So now we can come here, copy this line, paste it here, and then we can just render it wherever we want. It's going to be absolutely positioned, so it doesn't matter. And now if I hit save and then come back here, as we can see, we have this button here. And here we have two tabs. So we have queries and mutations, and we have fresh, fetching, post, stale, inactive, and so much more. So I'm actually going to commit this. So commit and then fit, or rather chore, integrate TanStack Query. And this is for the client. So if you're following along, there is no need for you to install everything. It is going to be there in remote. And that's it. Now we can start using TanStack Query. So where do we start? Let's start here in the message list. How can we perform queries? Now there are some issues with this approach. Again, we are just calling these once. If there's an error, then there are no automatic retries. It is going to be set in stone, basically. There is no way for us to tell the user, hey, something went wrong, click this button to refresh. We do not have that functionality, and we're not caching anything. We're handling all of the cache here, basically. So we're synchronizing manually the data we get from the server, so within this use effect, with this state. But now this becomes problematic because here in this WebSocket connection, we need to listen for those events and update the cache. So the data we have here. So now we need to introduce another state manager solution. We need to bring over Sustand or Redux or whatever. And we need to make sure to handle all of these states very well synchronized. So when we get the data, we need to synchronize the Sustand store. And then here in the client, we need to update the Sustand store. And there are so many steps that not everything is completely synchronized. There's really no source of truth in this situation. But TanStack Query is a state manager solution, an asynchronous state manager, if you will. So in this case, it is going to abstract the logic for setting the cache data. It is going to do it automatically for us. So to use it, all you need to do is bring over the useQuery hook. So from TanStack React Query. And then here we can pass in a lot of options. Now, one that is mandatory is the query key, which is an array of whatever you want. So an array of unknown, basically. And this query key must be unique, because this is what is going to be internally used to identify what data belongs to what in the store. So here we can say this will be for the chat. And then here you can pass in the query function. And then within this query function, you perform the query. So you can say return client.chat, then get, and then we just parse the JSON. And then we can get rid of this, and now we get back an object. So we can remove this use effect, we can remove the messages, because they are now going to be queried by the useQuery hook. And then here we can say const messages is equal to query.data. So whatever you return from the query function is going to be assigned to the data property. But of course, this can be undefined. Why? Because, well, the query isn't successful. At this state, it is pending pretty much. It has not been called, so we can default back to an empty array. And if we save this and then come back here, as we can see, we have this query. And the data explorer is the explorer for the state that was stored for this particular query. So this is why the query key is very important. And if we come here, we get each message. So everything is working as expected. Now, the great thing about TanStack Query is the amount of features it has out of the box. So if I come here and type in query dot, we get the data, we get when the data was updated, so when the query most recently returned the status as success. We also have the error, so the error object for the query if an error was thrown. That means that here you can throw whatever you want, and this is going to fail the query. So now it can never be successful because, well, we're throwing right away, and so we know that we get access to error. So it isn't null in our case. So if I console log error and then query dot error and then hit save, come back here, refresh, we get no data because, well, it failed. If I come here, as we can see, the data is indeed null. But if I inspect element and then come here, as we can see, the error is 5. So that's incredibly useful. You can just have some if conditions and you can just throw errors and they're going to be caught by the useQuery hook. So now we can show some loading statuses, the error statuses, whatever you want. So we can come here and actually say query.isError. So this is a boolean. And then we can say if this is true, then we can render a paragraph and then we can render the message of the error. So if I save this, come back here and refresh, the error is null because we're rendering the message, which is not what we want. And as we can see, we now get the 5 here. So we can style this up a little. So let's convert this into a div and we can say flex and item center and then justify center. And if I save this, come back here, as we can see, we're not getting the error right away. We get the error as null. And then after some time, we get the error here. And you might be wondering, why aren't we getting the error right away? And that is because TanStack Query is retrying automatically for us. So if I come here and say retry 0, it isn't going to ever retry. Once it gets an error, it is just going to return the error right away. So we can save this. And now if I come here, as we can see, we get the error immediately. So this is very useful if you have some queries that, well, they should just fail right away. Do not keep on hitting the server 3 times, which is the default. Or, well, you can put in any arbitrary value. You could say 2 or 10 or 100, whatever you want. But for demonstration purposes, let's leave it as 0. So here you would usually throw an instance of error. So you can say test. And if I save this, come back here, we get test here. So we can say here, oh no, something went wrong. And then this should actually be within a paragraph. So paragraph, and then we can render a button. and then we can say retry, and let's import this button. And then here on the onClick, we can actually pass in this callback function, which is going to invoke query.refetch, and this is a promise, so we can mark it as void. But let's add a loading status, so we can say query.isLoading. If it is loading, then we can just say loading. And if I save this, come back here, we get that small flash of loading, and then we get, oh no, something went wrong. And if we click on retry, it is going to retry the function. So let's move this up to 3, which is the default, then retry, loading, retries again until we get back the error. So again, oh no, something went wrong. And then we need the success because we only want to render this on success. So we can leave it as such. We can just leave this component and it is always going to be rendered. But in fact, we can simply say query.isSuccess. And if this is success, then it is going to render this. Now, what is interesting is TanStack Query uses discriminated unions. So in fact, it must have something like type state, and then we have the error state. So his error is true, and then we get access to the error. Then we have the success state. So his error is false, then messages, and we have the pending state. So here his loading is going to be true, and there is no data, basically. And then this is just a discriminated union. Now we're not discriminating upon anything here. So I believe they have a status or state. So state error, then state success, and then finally state pending. So this way, when you say query.isError, then TypeScript can narrow down the type and it is going to give you the error. And we can confirm this if I come here and then say query.error. As we can see, it is not null. We get access to it. If we were to do that here, so query.error.message, this is optional. We must use optional chaining because it could be null. So this is something to keep in mind. It uses discriminated unions behind the scenes. So same for success. If you say query.isSuccess, then we know that we get access to the data. So this is not nullable, basically. Anyway, we can now get rid of this. We can now get rid of this as well. And let's get rid of this. And now this should be working as expected. But let's actually add some artificial delay to the server. So here in the API, in the index file, here in the get chat, we're just returning JSON messages. What we can do here instead is actually say return effect.generator. And then here we can say yield. And then we can sleep this for 3 seconds. And we can pipe this through. And then we can say run promise. And now if I save this, come back here, as we can see, we get loading. And once it is successful, the chat is rendered. Now notice how when we refresh, the loading is just taking up this space. So it is pushing down the text area whenever we get the data loaded in. So for that, let's just add a flex 1 and then here another flex 1. That way it is going to take up all of the space, all of the remaining space basically. So this is pretty much it. If I come here, we can set the retries. We can have a garbage collection time. So this is the time in milliseconds that unused or inactive cache data remains in memory. So when a query's cache becomes unused or inactive, that cache data will be garbage collected after this duration. That means that if we pass in gcTime of 5000, it is going to be 5 seconds. So when the query is inactive and 5 seconds have passed, it is going to remove the cached data entirely. So if I come here and click on chat, after 5 seconds of it being unused, it is going to delete everything here. So it is going to force a refetch whenever it becomes active, basically. And we also have staleTime, and this is the time in milliseconds after data is considered stale. That means that if we say again 5000, after 5 seconds, it is going to mark this query as stale, and TanStack Query will retry, or rather refetch the query whenever it can. So you will most of the times be using staleTime. gcTime, you'll use it sparingly. Not because it is dangerous or anything of the like, but because it depends entirely on your specific needs. So keep in mind that you'll be using staleTime quite a lot. And then after this, we have other utilities. We have refetch on mount. So whenever the component is mounted, it is going to refetch again, refetch and reconnect. So when the user's internet connection is disconnected and then the application is reconnected, then you can refetch if you want, and then refetch on Windows Focus. So whenever this is true and we switch back and forth between these, it is going to trigger a refetch. So if I come here to network, clear this, come back here, as we can see, we get the fetch here, and we get another one. And this is used in conjunction with staleTime. So you can say only after 5 seconds. So if I save this, come back here, remove this, as you can see, it is not refetching because the time hasn't passed. But once the 5 seconds pass, it is going to refetch whenever it can. And in that case, it is when we go out of focus and into focus again. And we also have an interval. So this is for polling, basically. You maybe want to fetch the data every 30 seconds, maybe for a dashboard or something of the like. Then you can use refetch interval. And you also have in background. So when the tab window is in the background, so you can set this to true or false. Now you also have other properties, such as the retry delay. So you can add a delay. So you can say, okay, delay this by 1. Now I'm not entirely sure what this is going to do, if it's just going to delay by 1 second. So it fails, waits 1 second, fails, waits 1 second. I'm not entirely sure. You can check the documentation for that. You have the throw an error. So if this is true, well, it is going to throw the error to the component, which is not what you would usually want. And we also have the retry. So we know that we set the retry to 3, but in fact, you can get access to the attempt count and the error, I believe. So here, if you return true, it is going to retry again, forever, basically. But you can check if the attempt count is greater than 3, so we have already exhausted the retries we want to allow, then return false, do not retry again. Otherwise, continue retrying. But you can use this in conjunction with error, so you can check if maybe the user is unauthorized or it was a bad request. Who knows? You can do whatever you want here. And this is pretty much all of it, at least what you will be using. Of course, you can refer to the more specific and perhaps complex properties depending on your specific use case. So let's save this and let's set the staleTime to 30 seconds. Okay, so now with this, let's go through the cycle of optimistic messages, then replacing the message, handling errors, everything you would do with a state manager if you were going to do it imperatively, and that is for sending a message. So how can we turn that into TanStack Query? Well, if I come here to the chat footer, now here we have this call. So we call post. We can actually create this send message mutation is equal to useMutation. And then here you can pass in a mutation key if you want. And this is for identifying the mutation. So you can say send message, although this is not required. And then you can pass in the mutation function. So within this one, you can just do this. So return client.chat.post, and the trimmed message would actually come here. So message is string, and then you could come here and then say send message mutation dot, and then you can use either mutate or mutate async. So this is useful if you need to await the mutation, but in our case we can just say mutate and we pass in the trimmed message. And then here would actually be message. And that's pretty much it. We have now abstracted that within this hook. But now you might be wondering, why are we using a hook? Why cannot we just do it directly in line without wrapping this up? Well, again, because you get access to loading states. So you can say send the message mutation is pending. So this is the equivalent of is loading, but for mutations is pending. So is it pending a response from the server, whether that's an error or, well, success? You also have is error, you have is success, is paused, you have a lot of things here. You even have the data, which is the last successfully resolved data for the mutation. But aside from that, you have these two wonderful callbacks on success and on error. Now you have on mutate, which we'll check out in a moment. We also have unsettled, but let's focus on success. So here in success, we get access to data, then the variables, and then the context. We can omit the context. We have the data here and the variables. So the data is the result of this mutation, and the variables are the ones you passed here. So in fact, this would be the message. So we can actually rename these two variables so it's clear. And then we can say variables.message. And now we can say variables dot, and we get access to the message. So this is a callback that will be invoked whenever this mutation is successful. So here, when it is successful, you would usually say set message and then an empty string. And now you can get rid of this and we can pass in the message. So here, let's just prefix this. So seems like it is not working. Must be because the rule is not set for this. So we can remove this altogether. Now by doing this, if I hit save and then inspect element, then come here over to the network tab and then say test, hit enter. As we can see, we get the mutation here and we get the data back. And as we can see, it was reset successfully. So again, test, we wait some time and then it gets cleared. However, since this is a chat application, we want to show the optimistic messages, meaning that we want to render the message right away, even if the server hasn't processed it yet. And same with the input. We want to remove the message the user typed in. So how can we achieve that using TanStack Query? Well, actually, it's very straightforward. We can start off with onMutate. So whenever we call the mutation, we can create the optimistic message. So we can say optimistic message satisfies, and I believe it's chat message. And then here we can say ID, and we can say optimistic, and then we can say math.random, and then we can say the as to be, well, the current session. So whether the user sent it as John or Melissa, then we can pass in the content and then the created ad. And then we need to add this to the query cache. So we need to come here to this query. We need to modify the data to include the optimistic message. So how can we achieve that? Well, for that, we can use the query client, and then we can say set query data, and we must pass in the key of this query. So we can say chat, and then here we get the cached data, which we know are the cached messages. And now here we get unknown, and that is because we need to pass in type safety. So we can say this is an array of messages because we know this query is going to return to us an array of messages. So we can say cached data or return, and then we spread over the previous cached data, and then we pass in the new optimistic message. However, here's a problem: cached data is possibly undefined. And why undefined? Because the query might have never been fired, or it has never been successful, so there's no query data. In that case, we can just use a clause guard and say if cached data is equal to undefined, we can just return undefined. Or actually, we can return an array with optimistic message. So now here, if we send a message, so let's say this is a message, as we can see, we get the optimistic message right away. Now, if you've used WhatsApp, you would know that optimistic messages have this clock right here instead of a check icon. And I do have that functionality implemented, because if I come here to the get message status, we have optimistic, sent, and read. And here the ID, we have p.string that starts with optimistic. That means that here, this should be optimistic. And now if I save this, come back here, it should be showing optimistic. Let's refresh. Let's send a message once this loads. So message. And as we can see, we get this clock here. So it is working as expected now. However, what if the mutation is successful? We need to get the data from the server and replace the message so that we get this check icon. And what if it's an error? Then we need to remove the optimistic message from the list. So for that, we can come here to success and we can come here and say new message because that's the data, and then the variables and then the context. Now this context is very important because we need to pass in this optimistic message to the context so we know which ID to look for. So we can say return and then we can say optimistic message. And now here we get access to the optimistic message. So now we can copy this line right here. We can come here within the body. We can say if the cache data is equal to undefined, and we can just replace it with the new message, which we know shouldn't be possible because here we're setting it to be the optimistic message. But to make TypeScript happy, we can do this. And then we can say return cached data.map. And then we search for the message where the ID is equal to the optimistic message.id. And in that case, we can replace the new message, or rather the optimistic message, with the message from the server. If not, we can leave it untouched. Now cache data is nullable as well, so we need to save undefined or is equal to null. Now we're getting an error here because we need to convert these to JSON. But this is a promise, so we can say, so new message response, and then new message is equal to new message.json, but we can turn this into a sync, and then here we can just say new message. And now I believe we get the full type safety, so it works. We get as content created at and read at, but we're not passing the ID. So we can come here to the API, so packages, API, and then here for posting, we have the new message, which is this one. We should actually rename this to incoming message, or rather, yeah, let's keep it as incoming message. Then new message is equal to this. We push this and we return the new message. And now we get no errors. So now, when it is successful, we're replacing the optimistic message with the new message. And we can do the same for the server. So we can actually move this up over to unmutate. And then, or actually for separation of concerns, let's move it right before calling mutate. And now we can say on error. We get access to the error, we get access to the variables and the context. So error, we do not need the variables, and we do need the context, which is the optimistic message. So we can just say set query data, and we filter out that message. Now we're getting optimistic message does not exist on type, optimistic message, or undefined. So the context could be undefined. So if context is equal to undefined, then just return right away. Otherwise, context.optimistic message. And now we're handling all of the different states. So right on mutate, we add the optimistic message. On success, we replace the optimistic message. And finally, on an error, we remove the message. So now everything should be working as expected. So let's refresh and then say, hey there. And as we can see, we get the clock and we get the result of the mutation, and it is successfully replaced. So as you can see, by using a state management solution like TanStack Query, we simplify a lot of the logic. But there are some things we can improve here. The first one is performance. It is not wise to spread over and spread over and spread over because you're allocating a lot of memory unnecessarily. What if this was nested? Maybe you need to update a property that is very nested. you might see the spread hell, where you spread over that, then spread over the previous property, and so on and so forth. In that case, I would recommend making it mutable. That means modifying cache data directly without making it immutable, like we're doing here. But the problem is, TanStack Query advises you to never mutate the data directly. Now I'm not sure why, maybe to prevent some type of race conditions, who knows, but in that case, it's better to keep it immutable. But how can we do that? With good performance at the very least. Well, for that you could use something known as Immer, and Immer is the most popular library for immutable data. So it's a tiny package that allows you to work with immutable state in a more convenient way. So I believe they have an example here. As you can see, we're spreading over and then we replace the property. So we're cloning the element and allocating new memory. And you are repeating that over and over for a lot of deep updates. So as you can see here, deep updates are a breeze. But I do not recommend Immer because it is actually quite slow, at least compared to this alternative, which is Mutative. And this one is the same as Immer. I believe it has pretty much the same API, but it is way more efficient. As you can see, 2 to 6 times faster than naive handcrafted reducer and more than 10 times faster than Immer. So I'd recommend using this one instead. So for that, let's come here and let's add Mutative, or bun add actually, and this is in apps client, so bun add Mutative. Now we're getting this error here, so again remove everything, cd back into client, and then bun add Mutative. And now we're getting this error because we need to run bun install at the root, and now I can come here and say bun add Mutative. And now we can start using it, which is actually very straightforward. Import, create, or produce, I'm not quite sure, from Mutative. So I believe it is create. Yeah, it is create. So we can come here and instead of doing this, we can just return and then create. We pass in the original data and then we get the draft. And then here we can modify, mutate the draft however we want to make it mutable. So we can just say draft.push and that's it. And we can do the same here. So return, create, and we push the new message, but we actually need to replace it. So optimistic message index. We find the index and then we replace it all together. There's no need to return it because again, it is mutable, and we can do the same thing here. So create, we find the index of the optimistic message, and then we can say splice and we pass in 1 to remove that element. And that's pretty much it. Now we can hit save. We can come back here and as you can see, test. It is working as expected and it is being replaced. So now you get a way better API because, well, you can just mutate the data directly, but you're still making it immutable because you're modifying the draft, not the cache data. Now, the second thing we can improve is type safety, because right now we're typing the query key manually. But what if it changed in the future, or maybe we introduce a typo and we forgot about the T? Now this is not going to work and we'll spend countless hours debugging. So for that, what I would recommend is actually creating a wrapper hook around this with all of the type safety. So here I'll say reveal active file, and here we can actually come to the lib directory and we can create a hooks directory, and you'd usually call these not hooks but rather API or data access. And here you would create the use, and this could be messages query.ts, and then you would copy this query and then say export function use messages query, and here you just return use query and you import the client. So you're also abstracting this away, but usually create a query function like this, and then you can just return it here, and this is going to return type use messages query function result, and we know this is an array of chat message, so we can enforce the types here as well. And well, this is a promise actually, so promise, and then we can point this to be just the query function. And now as for the query key, I would actually create another type, which is type use messages query key, which is a tuple with just one element. And then you would say this satisfies the use messages query key, and you would export this type and also this one, and then you would come here to the message list and say use messages query, and that's it. Now you have abstracted that away and everything works just fine. And here in the chat footer, instead of doing this, you'd actually create the messages query key satisfies use messages query key, and then you get the chat. And you do the same for this one, and that's pretty much it. So messages query key, and you would point that here as well. And as for the type, you'd say use messages query function result, and you'd paste this here as well. So now this is way more type safe, because we know that if we change here something, so wrap this in an object, whatever, TypeScript is going to yell at us for trying to do this. And also for the query key, if we change this to chat2 and then come here, we now get a type error. So this is incredibly important. Now we should also extract the use and message mutations. So here in the chat footer, it wouldn't be wise to have all of this code here. So for that, we can copy this whole mutation and then say use send message mutation.ts, and then we can export function use send message mutation, and we return a use mutation. And then we need to import all of this. So chat message, then the query client. What else? We need to import this one as well, and the create from mutative, and I believe that's everything, and the client. And now we need to come here over to the chat footer and say use send message mutation, and we can get rid of all of these imports. And now this is way cleaner and everything is abstracted here. Now if the cache updates were to get more complex, you would also extract that to its own file. And in fact, I would recommend doing that, because you should have unit tests for your cache updates. All of these should be tested no matter what, because this is so easy to mess up. You might accidentally introduce a new property, whatever, and you forgot to update that. So please make sure to write unit tests for at the very least the cache updates. Now I'll commit this, so git add everything commit and then fit, and this is for the data access, and use messages query and use send message mutation. And I'll actually not push this over to main, but rather create a feed data access, and then here I'll push this to fit data access. So you can find the code for this in this branch. And now lastly, what we need to do is update the WebSocket connection to use the query client. So this is pretty easy. We can say switch event data dot type, and then we can say in the case that it is a new message, we can do something. So for now, let's leave it untouched, and same with this one. So now here, we're not going to implement this, at least the logic for marking the messages as read. And in fact, I won't do this because I want you to implement the logic, calling the optimistic update for the cache, reverting the change on error, the whole flow basically. So now in this case, but actually I'll leave this as a to-do. So implement read message mutation, or use mark message as read.ts. So that's your job if you want to learn the library, of course. Now here we can say const and then query key, so messages query key, and then we can say query client dot set query data, and then use send or use messages query function result, and then if all data is equal to null or all data is equal to undefined, return the all data, but this is actually the cache data, and then we can return a create from mutative, because passing the cache data and then the draft. Now in this case, we need to check if it exists. So message exists, and we find the message where the ID is equal to the message.id from the WebSocket connection. If it exists, then don't do anything. And in fact, in TanStack Query, when you return undefined from the updater, you're signaling TanStack Query to leave the cache data untouched. So in fact, we should do this here. So copy this and return undefined, and this refers to signals TanStack Query to leave the cache data untouched, and here this would be cached data, and then we can remove this check and just create the copy of the cache data when we actually need to push that. So we can say draft.push and then the event data.message. Now we're getting an error here. Let's wrap this up in brackets, and that's it. Now this should work. So now let's try it out. Here I'm in as John, so on the left side, and on the right side, Melissa. So if I say, hey, John, as we can see, we get hey, John right away, but we're getting them duplicated. So again, test2, and it is not deduping them. And the reason is because the WebSocket connection is sending the new event faster than we actually replace the optimistic message. So we end up with duplicated messages. So to fix this bug, it should be as simple as coming here to the use and message mutation, and then on the success, we check if it exists. So const message exists, and if it does, well, we leave this untouched. So I'll leave this comment here as well. Now if I save this, come back here, let's try it out. So as you can see, the duplicated messages went away. That is because the query became stale and TanStack Query refetched the query. So as we can see, it is fresh. So it basically deduped it for us since it went over to the server, retrieved the data, and replaced it all together. So that's really nice of TanStack Query. Anyway, if I say test3, now it is not being replaced. So in this case, we need to remove it if it exists. So we can get the index for the optimistic message, and then if it exists, we can say draft.splice and we just remove it. Otherwise, we can add it, but not push, but rather draft add the optimistic message index is equal to the new message. And then we can remove this, come back here, and now it should work. Test 4, and it was removed. So a quick fix is just deduping them at the rendering level. So we can revert all of these changes and this one as well. And now we can come here over to the use messages query and we can dedupe them here. So we can say return, or not here, actually in the message list, we can say const messages is equal to react.useMemo, and then here we can say whenever the data changes, or just the query, we can recompute this and we can say query.data, we can remove this, and then we can say non-nullable messages is equal to query.data or an empty array. And then here I would actually recommend using Remeta, which is a great functional library. So we can add this library. So again, go back to the root, remove everything. So remove package or recursively node modules. Then we can come back and say bun install. And then I believe we can come here, say bun add Remeta, and we get it here. And then Remeta has a function which is unique by, if I'm not wrong, returns a new array containing only one copy of each element in the original list. So we can say unique by, we pass in the array and then the function. So we can come here and say import all as remeta from remeta, and then we can say r.pipe, and then we can say non-nullable messages, and then unique by, and I believe we can just say message.id, and then we can sort it by created at. And now if I save this, come back here, test 5, and as we can see, they are now not duplicated because we're deduping them here. Now, of course, this is a quick solution, and this is not recommended because you still have the duplicated items in the cache. And when you want to update a particular item, which one are you going to update? The one that is being consumed here, or the duplicated one that is never seen anywhere? So that's why you should also come here to the client and handle that here, as well as in the other side, just to ensure that, well, you have no duplicates. But that's up to you. If you want to continue working on this project, get your hands dirty and learn more about TanStack Query. Anyhow, this wraps up the video. If you want to see more content like this, make sure to subscribe and like the video. I'll see you in the next one. See ya.